Hi, it's Jan Beta, and as you can see, I have this 1541 Mark II that I refurbished, so to say, in one of the previous videos. I will link that in here. And the problem is that I have another one, and this came without a power supply, one of these things. So I had a little look around for a replacement power supply to be able to use this and the second one at the same time, maybe. And yeah, these original ones are quite expensive, I thought. So I looked around a bit and I came across a German forum, digitalfacts.de, I will link that in below, where someone suggested a switch mode power supply, or switching power supply as they are called, as a replacement that delivers the same voltages like this one and only costs €2. So that's a price I'm willing to pay and see if it works. And if it doesn't work, it doesn't matter much because it's so cheap. So what I'm gonna do is to use the forum post, and I actually bought the replacement that was suggested there for €2. And I will link in where I bought it below in the description, I think, if I can find it. And yeah, this basically delivers 5 volts at 1 amp, 12 volts at half an amp. So that's exactly what the old brick delivers. And it also is supposed to have, I haven't opened this at all, so this is going to be a little bit of an unboxing as well. It's also supposed to have a DIN connector, but a DIN connector that's a bit different from this one. So I also got myself some DIN connectors. These are the 4-pin DIN connectors. I will also link that in the description, which ones you need there. Yeah, these are basically the ones that fit the power in on these drives. So let's open this up and see what it's all about. And then I'm going to make some tests. Okay, so here we go. This is the first time I'm looking into... Oh, this looks tidy. It's very light, which is normal for switching power supplies. Oh, and it also has rubber stands and stuff like that. Yeah, and the cable doesn't feel too bad. And it also has 2 of these connectors, so you can connect another thing there, which probably isn't a good idea because of the quality of this thing. I wish I could take a look inside here. Maybe there are screws underneath these rubber feet here. Let's see. And sure they are. Haha, can't fool me. So let's see what's inside. There we go. Yeah, there it is. Doesn't look too bad, actually. There's a fuse. That's a fuse. A 2 amp fuse. At least the mains is fused. Yeah. What? It's a Samwa brand cap, and the other ones are KMF. Probably quite cheap stuff. But it looks reasonable, I would say. So here's the money shot. This is what this is. An on command AP12UV/1 or -1. Yeah, 5 volts 1 amp, 12 volts half an amp. The other voltages we won't need. seems legit, and the quality isn't too bad for €2. I mean, yeah. Some cutting edge technology. There we are. So let's measure which one is which, let's say. I think the forum mentioned the color code that the person who wrote the forum post had. Let's see if it's the same at first, I guess. So I have the multimeter here, and the black one is supposed to be ground. So let's use it as our ground. And the two red ones are supposed to be 5 volts DC. So I don't want to short anything, so I'll be a bit careful. I have it on a switched outlet here. Let's switch it on. And there's 5 volts on the red one. Switching off. Here's the other red one. That should also be 5 volts. Let's see. Yeah, and it's also 5 volts. So the blue one should be 33 volts. Let's see. And yeah, not quite 33, but close enough. And what else do we need? 12 volts. Where is 12 volts? The yellow one should be 12 volts. Let's see. Yeah. Tiny bit low, but 12 volts, more or less. So yeah, so the color coding is the same as in the blog post. That's cool. So far so good. Let's, I think, solder on one of our plugs and then see how it fares. So the ones we need are black, red, and yellow. So the other ones, I'm gonna cut it. So let's get the pin configuration of the 1541. I have a picture somewhere that I will show here. And then solder this on. So you just pull these apart basically. And of course it takes some patience and force because they're quite sturdily built. I'm gonna tin these contacts and then I'm gonna put this over there. Never forget that. I tend to always forget it and have to remove the plug again, and yeah. Okay, so here's how these things work. They're basically just, you can open them like this and have two halves, and here are the connections. And normally you can just get it out there, which is not easy in this case because it's quite a good connector. Let's use some force. Yeah, there we go. So here we are. This is our connector we want to solder on. And when you are soldering to something like this, always use some device that's holding it in place, like this third hand, or I don't know, a little vise or something, because basically these will slip if you try to solder on them. Okay, so this is our pin out. This is pin 1 from this side, and it should be 12 volts. Pin 2 is not connected. Pin 3 is our ground, and pin 4 is our 5 volts. So it shouldn't be too hard to get the connections right there. Let me try. Oh, and this is the nice connectors of this kind, where there's little holes in the pins, which is much easier to solder on. So this is our new plug, which should have the right pin out now and the right voltages. And it locks itself in place when you put it in there. Nice. Plugging it in. The plug fits. It's a good sign, I guess. Let's see. I want to turn this around and then flick the switch. Okay, and so let's first, I have to turn on the power here. Let's see if nothing explodes. So the wiring on the plug can't be that bad. So let's turn on the drive here. Yeah, sure enough, it spins up and seems to work. Yeah, this sure looks convenient, and yeah, looks nice, but this is also a bit of an electronics channel, so let's see what this PSU power brick thing really puts out, and if this, how well this 1541 takes it. So this is very basic because I don't have the proper testing equipment for this. Yeah, I'm just a hobbyist, obviously. You could measure this very precisely and stuff, but yeah, basically what I did, I made loads. This is a 25.6 ohm load that I made of some bigger resistors I had laying around, which is a bit higher resistance than the 0.5 amps that the 12 volt line has to pull on a full load. So it's not quite full load, but a little tiny bit lower, which is probably realistic because it won't run under full load on the floppy drive normally. So yeah, basically this is the load for the 12 volt line, and test if it can deliver the voltage at full load. And this one in the background there is an 8 ohm load, or it's really 2 8 ohm loads, but we're gonna use one, which I made for testing audio amplifiers a while back. You've probably seen me using this in a very early video. I think I used this on the Sansui that I was repairing. Yeah, so maybe I'll link in the video so somebody watches the video at all. The old videos don't get many clicks, of course, because yeah. Yeah, so this is an 8 ohm load which will pull some watts out of the 5-volt line, you would have, to get the whole 1 amps that are in the specs, you would have to use a 5 ohm resistor, but I only had this 8 ohm resistor, which is probably close enough, I would say. So we're going to use that as our load here, and yeah, so I don't have to be afraid that this blows up, because there are basically 5 watts power going on, a bit under 5 watts, because it's not quite fully loaded. So yeah, let's see if this can deliver the voltages under some load, or nearly full load, and then compare it to the voltages that the original PSU could deliver. That's the plan. So I am connecting the ground pin, which is pin 3, which is this one here, from this side, and pin 1 should be plus 12 volts, which I'm connecting to the other side of the resistor, which is this pin here. And I'm trying to insulate it so that it won't short out there. Yeah, I would say power on. Let's see. Oh, yeah. And that's what I thought. It's not even full load, and yeah, it basically only delivers 10.4 volts there. Maybe enough to power the drive, but yeah, it's not 12 volts at all. So yeah, that's the 12 volts of the new power supply. Let's see what the old power supply does there. Okay, I've now connected the same pins on the old power supply, and I'm going to turn on the thing. Oh, okay, that just went out. And as you can see, this delivers more than 1 volt more than the cheap one. So yeah, that's quite good. And yeah, this is a classic power supply with, it's not a switching power supply, it's just a transformer and the voltage regulator and rectifier and yeah, probably something like that in there. So let's turn it off and see what the 5 volts do. Okay, so this is the old power supply connected to the 8 ohm load, and the 5 volts should be connected now, so let's see. Oh, and that's full load on the old one. 4.5 volts. It's not that bad, I would say. Let's see how the new one handles that. Okay, so this is the switching power supply connected, the 5 volts line. That's probably it's the more important line, because all the ICs are powered by the 5 volt line, I guess. Let's see what this does when I turn it on. Yeah, that's not too bad. That's quite on par with the old power supply, I would say. You had 0.1 volts more or something like that. That's not too bad, actually. It's not the 5 volts that the specs promised, but it's pretty close to the original PSU, so it probably will do. Let's see what this looks like on the scope. I brought out the scope. What I'm trying to do is to make a very crude measurement of the ripple and the noise of the power supplies and compare them maybe. So here's my setup. It's under load. This is for the 5 volts. the other load is behind there at the moment, so I will connect it basically like when I measured the voltage, same way, and then connect the scope probe over there and see what we get. So this is the 5-volt rail on the replacement PSU. And as you can see, there's quite some, I would say, ripple on there. Yeah, that's definitely. And there also seems to be some high frequency stuff going on there, but the scope isn't really made for that. But it's in the range of, let's say, this is 1 millivolt per division, so it's not very much, I guess. It's a couple of millivolts. 1, 2, 3, 4, 5 millivolts per division, so it's 25 millivolts or something like that. That's okay, I would say, under load. So let's check the original PSU. Okay, exact same setup, except I have connected the original PSU. Let's see. Okay. Let's turn on. And as you can see, there's not much to see. Very clean stuff going on here. Yeah, so that's all we get from the original PSU. So that's not too bad. There's some high frequency stuff going on there. I can't really focus on, but it's not much. That's not too bad. Let's turn this off. This is not at all an appropriate method to measure ripple and noise. It's just basically to see how bad the cheap PSU is, I guess, and how good the original PSU is in comparison, maybe. So this is the original PSU, the 12-volt line, connected to a load. So there is some stuff going on there, but it's not much there. Oh, it's barely visible. Some high frequency stuff going on there, but it's not much. It's 2 millivolts or something like that. Not that bad. Not that bad at all. So let's see what the cheap PSU does on the 12-volt rail. Okay, here's the 12 volts on the new PSU. Wow, okay. So that's definitely not good. Look at this. So you can see, yeah, it's not that much, but it's 5, 10, 15, 20 millivolts of stuff going on there, and high frequency stuff as well. So there's some weird noises going on. It's probably a lot of interference there. So that's not too good, especially compared to the original PSU. So I wouldn't at all recommend the cheap replacement. Let's see if it works I guess, and get the Commodore 64 out and try if the drive even works with the cheap power supply. Oh, and if you want to know how these ripple and noise measurements work, if a professional does it, there's a video by Dave of the EEV blog, I will link in here, that explains in detail how you are supposed to do it if you want to do it right. I did it, yeah, it's a very crude way to do it and it's not very accurate, but as you can see, you could see major differences between the two power supplies, which was kind of the whole point, so works for me. Okay, I made this diagnostics cartridge myself. There's gonna be a video about that. I haven't finished yet because I want to show other things. Basically, it's a combined Commodore 64 and 1541 diagnostics cartridge, which you can switch. So I switch it on 1541. And insert it, and it should give us the 1541 diagnostics. So let's see if we can do the performance test with the disk inside. Performance test. It seems to do what it's supposed to do. And now I should drink some coffee. Let's go. It seems to work, but I know now after measuring the ripple and stuff that I wouldn't recommend this power supply at all. There is a good one I saw recently that Greisi built. I will link in his video. He also built a very good one for the Commodore 64 as far as I can see. I'm obviously not an expert on power supplies, but it seems very legit what he built, and it's at least it's far better than this little cheapo replacement unit, which seems to work. As you can see, the mechanical test is okay, which is not bad. Yeah, so it's a replacement, an emergency replacement, I'd say. So I guess I'm gonna build something better, but seems to work for now. Okay, it passed the test, no problem. Let's see what else we can do. Maybe we should do an alignment check. Let's see what that does. Space to check. So this does an alignment check, and it seems to be perfectly aligned, which is great. 100% on track. It's actually the first time I'm using this diagnostic card, so that's also kind of an adventure. Yeah, but that drive seems to be in perfect condition, I guess. And it works with the replacement power supply. Yeah, but this seems it's not too bad. Nice. Last one is 100, because there's no between track, maybe. I don't know. Okay, F1 to exit. So, do we do the speed test? Let's see if the speed is quite accurate. It's just 0.4 RPM off, or 0.5. Yeah, so I would say this drive is except for the optical issues, in perfect condition, and it's working perfectly fine with the replacement PSU. So that wraps it up. I wouldn't recommend this PSU at all, but it seems to work. So yeah, if you don't have any money and still want to read your discs, basically you can do it like I did it in this video. So anyway, thanks for watching. Hope to see you again sometime soon on this channel. And yeah, if you want to support me, there's links in the video description. So thanks for watching. I'm Jan Beta. See you next time. Bye!